we will first of all we will discuss about the force, and then we will discuss about the laws of motion. So let's see what is the force. Okay. So actually force is an external effort. It is an external effort which may move a body which is at rest, or which is at rest, or it can stop a moving body. It can stop a moving body. Okay, means if a body is stationary, if a body is stationary, then by applying force on it, the body will start moving. The body will start moving. And if a body is already in motion, if a body is already in motion, then the force applied on it can stop the body. Okay, these are the two effects. It can also change the speed of the moving body. It can also change the speed of the moving body. Means if someone is, suppose if someone is cycling, okay, and if we are pushing, uh, if we are pushing it from the back side, from, suppose from the back, if we will start applying force on it, we will start pushing the cycle, the speed of the cycle will change, right? The speed of the cycle will change. It means the speed of a moving body can be changed. Next is change the direction of a moving body. For example, in cricket, okay, when ball is thrown towards the player, okay, so the batsman hits the ball, the batsman hits the ball, and because of which the direction of the ball completely changes. Okay, the direction of the ball changes, and so the direction here, the direction has been changed by applying the force by the bat. Even the shape or the size of a body can be changed. Okay, for example, if a balloon if a balloon is pressed from two sides, then the shape will change. Or if a spring is stretched or it is compressed, in both the case, if it is stretched or it is compressed, in both the case the size of the spring will change. Okay, if it is stretched, the length will increase. If it is compressed, means the force are applied inwards, then the size will decrease. Okay, so this is about the size. And about shape, we can take an example of balloon. We can also take an example of the dough that is used to make rotis or chapatis. Even the example of clay, even in that case, the force is applied to change the shape of the body, right? So understood this, that these are the force which can do all these kind of changes in a body. So if such kind of changes is taking place, we can say that force is acting on a body. Okay. Now, so if it is asked that what are the effects of force, then you will be writing all these 5 points. The first point is force can move a body at rest. Second point is force can stop a moving body. Third point is force can change the speed of a moving body. Fourth is force can change the direction of a moving body. And finally, force can change the shape and size of the moving body. Okay. If it is asked to give an example along with these effects, I hope you all are able to give an example, right? Just now we had discussed few examples based on each effects. Okay. Now we will discuss the two types of force, that is balanced force and unbalanced force. So let's first we will start with the balanced force. So what do we mean by balanced force? So if two forces acts on a body, okay, it can be, and actually it can be two forces or it can be more than two forces. If two or more than two forces acts on a body in opposite direction, this is important. It should act in opposite direction, and if both the forces are equal, both are having the same magnitude, then the resultant force acting on the body is zero. Then the resultant force acting on the body is zero. Either we can say resultant force, or we can also say the net force. The net force acting on the body. Okay, means any both the word means the same thing. So if such kind of forces acting which are opposite in direction and equal in magnitude, then such forces are called balanced force, right? Here we can see in a figure that on a box the forces are acting in opposite direction, and it is mentioned that both are equal. So these two forces are the balanced force. Okay. So now just let me know that whether the object will move towards F1 or F2. Any one of you can. Yes, Ananya?
Sir, if
So the
the
body will not move.
Yeah. The body will not move to any one side. The body will not move to any one side because the force acting on them is equal. And we know that to find the equivalent force, we have to add the forces if they are in same direction, and we have to subtract the forces if they are in opposite direction. So here they are in opposite direction, so we will subtract them. So whatever may be the value, say if it is uh, 7 Newton, so 7 minus 7 will give us 0. So though the forces are acting on the body, but the net force or the resultant force acting on the body is 0 Newton, and so we can say that the forces acting on the bodies are balanced force. Means it is vice versa. For a balanced force, if a balanced force is acting, always the net force or the resultant force would be 0. Or if the resultant force is 0, we can say that whatever forces are acting on the body are balanced force. Okay. So here, as like you said that the body will not move in any one direction. So same thing has been mentioned here, that balanced force cannot change the state of rest or motion of the body. Means if this was an example for the state of rest, means the body was at rest and it didn't move when balanced force acts, when a balanced force act on it. But even if a body is moving, means suppose even if a body is moving, means say that you are riding a cycle, you are riding a cycle and you are riding a cycle on a road, and the force applied by you is equal, or yeah yeah if it is equal to the force applied by the friction by the air and the road, if it is equal to the force applied by the friction due to the road and the air, then your motion is going to be your speed is going to be same. Means if suppose you are at 10 meter per second, if you are riding at a speed of 10 meter per second, then your speed will not change unless any external force acts on the cycle. Unless any external force acts on a cycle. Means suppose uh, if the plane is inclined, if the road is like this, then obviously the gravitational force will start acting downward, and the speed of your bike will increase or the speed of your cycle will increase. But if you're continuously riding on a plain road, on a horizontal road, and if no other force is acting, then you will keep moving with the same speed. Okay. So the motion of the object is also not changed if a balanced force is acting on a body. Okay, so balanced force can neither change the state of rest, neither it can change the state of motion of a body, right? So it means what? It means what? Whenever in any example, if we are referring to a force, that a force is applied on a football, or a force is applied to push a car or to open a door or whatever, anywhere, wherever we are using the word force, so that force is not balanced force. That force is not balanced force, because if a balanced force is applied, the body is not going to move, or the motion of a body is not going to change. So if a motion of a body is changing, it means the force applied is not balanced. It is an unbalanced force, right? So this was this was about the balanced force. Now we will discuss what is unbalanced force. Yeah. So the definition is almost similar. If two forces acts on a body in opposite direction, and if one force is greater than the other, then the resultant force is not equal to zero. Okay. Or what we can say, that if the resultant force F is not equal to zero, if it is not equal to zero, if it is not equal to zero, then the forces acting on the body are the unbalanced force, right? They are the unbalanced force. So it is, so such forces are called unbalanced force. Here is an example. The figure shows that two forces, F1 is acting on left side, F2 is acting on the right side, and it is mentioned that F1 is more than F2. F1 is more than F2. Let us take the value. Let F1 be say 7 Newton. Let F1 be 7 Newton and F2 be of 3 Newton. Okay. So if we will calculate the balanced force, sorry, the resultant force, then F equals to F1 minus F2, right? This is the formula that we are using to find the resultant force. That would be 7 minus 3, which will give 4 Newton. And what would be the direction of this 4 Newton force? It would be in direction of the greater force. Okay. So it means what we can say that a 4 Newton force is acting on the body towards the left side, right? The net force is 4 Newton, it is acting on the body, and because it is not zero, this the forces, that is F1 and F2, are known as unbalanced force. Okay. And an unbalanced force can change the state of a rest or the motion of a body. It can change the state of rest or of motion of a body. Means if a body is stationary, it can move a stationary body, or if a body is already in motion, either it can bring the moving body at rest, or it can change the speed of the moving body. Either it can increase the speed or it can decrease the speed, right? Okay. Now, uh, okay, so in this case, actually two forces were acting over here. But if suppose if F2 is not there, if F2 is not there, okay, this force F2 is not there, only a single force is acting on it. Means suppose a door is there and you have to open the door, so either you will push or pull the door to open it. If you are outside or inside, it depends on that. So either you are pushing or pulling a door, so in that case the force is being applied from only one side, right? The force is being applied only on one side. So even that is a case of unbalanced force. Even that is the case of unbalanced force, right? Okay. Now I'm giving one more question to you. If suppose two more forces acts from these two sides, from top and bottom, let this force be of 2 Newton, this force be also of 2 Newton, okay, this force be of 7 Newton, and this force be of 3 Newton. Now let me know that whether the result, means the overall force acting on the body, are balanced force or unbalanced force. You can type in chat box, all of you. Just type, if it is balanced, just write down BAL. If it is unbalanced, then UNBAL. Now, listen to me. Here, always to find the resultant force, we have to solve the forces acting in opposite direction. Okay. So if these two forces are solved, means if these two forces, we will try to take out the resultant of these two forces, that is 2 Newton and 2 Newton, then of course it is going to be 0, right? Because they are equal and they are in opposite direction. So that 2 minus 2 will give us 0 Newton. Okay. It means what? Vertically, the forces acting vertically are balanced. The forces acting vertically are balanced. Now let us discuss about these two forces, the F1 and F2. As we have already done the calculation for this, that the resultant force for the forces acting horizontally was 4 Newton, right? It was 4 Newton. So if the force acting vertically was 0 Newton, what it is equivalent to no force acting on the body in vertical direction. So we can directly eliminate these two forces. We can directly eliminate the forces acting in vertical direction. So the only force acting on the body is F1 and F2, and whose resultant is 4 Newton. So we will say that finally we are having some value. It is not 0. So the force acting over here is unbalanced force. Unbalanced force, right? So this is the correct one. That is the force, the overall force acting on the body is the unbalanced force, right? So if more than two forces acting on a body, then this is how you have to check that whether it is balanced or unbalanced. Okay. Yeah. So, okay. One more thing. Uh, just let me know that we had discussed that balanced force. Okay. This balanced force, it cannot change the state of rest or of motion of a body, but can it change the shape or size of a body? If yes, give an example in chat box. If yes, give an example in chat box, all of you. Either write no or write yes and give an example. Okay, so we can say that it can change the shape, the balanced force can change the shape, and examples are clay, duff, balloon, spring, rubber band, etc. Okay, so now moving on to the next topic. Force of friction. Okay, you all are familiar with the force of friction, as we have discussed this. So force of friction is the force which opposes the motion of an object over a surface, right? Okay, just let me know that uh, can only solid can only solid surface apply the force of friction, or all the three, that is solid, liquid and gas, apply the force of friction? Either write all in chat box or write only solid. Either write all in chat box or whatever you feel, either solid or liquid or gas or all. Only two of you have answered. Yeah, Nimisha, Rashi, Ananya, Deepika, Jan. Okay, yeah. So you are correct. All the three, that is solid, liquid and gas, applies a force on the body. That is they applies a force of friction on a body that moves through them. Okay. So here's an example. A ball rolling on a ground. It gradually slows down and comes to stop, which is because of force of friction, right? Even in case of a bicycle, if we stop pedaling a bicycle, the bicycle gradually slows down. Why? Because the force of friction is acting over there, and it comes to stop due to the force of friction. Okay. Just let me know that in both these cases, where the force of friction makes the body to stop, or the body slows down, or the body stops due to force of friction. In this case, the force acting on the body, that is either the ball or the bicycle, that force is balanced force or unbalanced force. That force is balanced force or unbalanced force. If a if a ball or a bicycle slows down or it stops because of friction, so during that time when it is slowing down, the forces acting on the bodies are unbalanced or balanced. Only three has answered: Deepika, Ananya, and Nimisha. Others, our audience, yeah, Rashi and Akash. Yeah, yeah, you all are correct. The force is unbalanced force. The force is unbalanced force. So remember one thing, that the state of motion, the state of motion, you have to remember one thing, that the state of motion or the state of rest can be changed only by unbalanced force. Only by unbalanced force. Just make this thing clear, that if the speed of a body is increased, if if the speed of a body is decreased, if a stationary body starts moving, or if a moving body stops, all this is possible. All this is possible only by unbalanced force, right? All this is possible only by unbalanced force. So even in case of these two example, the force acting on the body, that is either the cycle or the ball, that is the unbalanced force, right? So we can conclude. So we can conclude that if a body is moving in uniform motion, the force acting on it are balanced force, and if a balanced force is acting on a body, the body is obviously going to move in uniform motion. Okay, and exactly opposite, if unbalanced force acts on the moving body, if unbalanced force acts on the moving body, then its speed or direction of the motion changes. Its speed or direction of the motion changes. Means suppose uh, suddenly one of your friend starts pushing your bicycle from the back. Okay, from backside, if someone starts pushing your bicycle, then your speed will increase. Your speed will increase. It may become 15, it may become 20. Okay, so here is a change in speed. Here is a change in speed. Okay, understood. And if someone starts pushing the your bicycle from the front side, then your speed will decrease. It may become 5 Newton or 8 Newton, right? Sorry, 8 meter per second. So the speed can either decrease or it can either increase if an unbalanced force acts on the body. Okay, and if suppose you are riding, and if someone pushes your cycle from the side, so the direction of the cycle will change. The direction of the cycle will change, and that is also an example of unbalanced force, right? Okay. So this is about the unbalanced force. Understood? Now, if the unbalanced force, if the unbalanced force is removed, then it will continue to move with the speed it had acquired till then. The speed that it had acquired till then. Now, what does it mean? Suppose, uh, suppose that on a bicycle, on a bicycle, if there is a bicycle and someone is pushing the bicycle, okay, if someone is pushing the bicycle, suppose one of your friend is pushing the bicycle for the 10 seconds. So while pushing, your bicycle will keep moving forward and the speed of the bicycle will keep increasing. I mean, suppose initially it was 2 meters per second, then it became 5, then the speed became 8 meter per second, and finally the speed became 10 meter per second. The speed became 10 meter per second. So now the speed acquired by the bicycle is 10 meter per second, and if your friend will stop pushing the cycle at that moment when the speed was at 10 meter per second, so your means the unbalanced force has been removed, then the bicycle will keep moving with the same speed that it had required, that is the 10 meter per second. But the condition is there should not be any friction from the ground. There should not be any friction from the ground. Okay, understood this? Is this clear to everyone?